So now we have done what we did, a few examples. Now let's take up some applications of what we have learned, what inverse ratios are, what compound ratios are in problems. And we have a few interesting problems happening here. Let's check. Let's see what we have first. Okay, now here we have a case wherein you have Anand earns rupees 80 in 7 hours and Pramod earns rupees 90 in 12 hours. The ratio of their earnings is what? Now if you choose to confuse yourself, you could get confused. But here, when you're talking about the ratio of the earnings, it means the ratio of their earning capacity per hour. So if it is 80 in 7 hours, how much could it be in 1 hour? Or how much could it be in 7 into 12, 84 hours? What will be their earnings? So let's take it in terms of earnings per hour. That is their ability to earn. So Anand's rate of earning per hour is, say, 80 by 7. We'll try an alternate method too. And Pramod's rate of earning in 12 hours, he earns 90 rupees. So that means in 1 hour, he earns 90 by 12. And you need to find the ratio. So obviously, you'll divide the antecedent by the consequent. So which is the same as 80 by 7 into 12 by 90. So this gets cancelled and you have 3 and you have 4, which is 32 is to 21. So the ratio of the earnings, in other words, ratio of their earning capacity is 32 is to 21. We can even do it by another way. We can do 7 and 12. Their LCM is 84. We can even say 80 into 12 upon 7 into 12, because you want to make this 84, divided by 90, 12 into 7. So this has to be multiplied by 7 too, upon 12 into 7. So when you divide, you get 80 into 12 upon 84 into 84 upon 630. And this gets cancelled. And even over here, if you simplify this will turn out to be 32 is to 21. You can take your calci or simplify it. So either ways, the ratio of the earnings is going to be 32 is to 21. And are we right? Let's check it. Yes, we do have the ratio of the earnings. That's 32 is to 21. Remember, the inbuilt assumption is their earning capacity. Let's move over to the next problem. Okay, here we have a new concept here. We have P, Q and R are 3 cities. The ratio of average temperature between P and Q is 11 is to 12. Is 11 is to 12. And that between P and R is 9 is to 18. So basically, this is a continued ratio, but it's broken up into 2 ratios of 2 terms each. But both the ratios have a common term, which is in any case P in this case. Now here let's see, we have P by Q is 11 by 12 and P by R is 9 by 8, and we need to find Q by R. Now there are various ways of doing these questions, but in this particular case, since we have to find Q by R, we need to eliminate P. If we need to eliminate P, the only way we can either multiply these 2 ratios, which is not going to eliminate P, it will make it more compounded. So we can divide these ratios. So when you divide these ratios, you get P by Q divided by P by R, and this side it is 11 by 12 divided by 9 by 8, and here we have P by Q into R by P, and this is 11 by 12 into 8 by 9. So here we have P gets cancelled, and here you have 4 2s are and 4 3s are. So we have P by Q into R by P. It's 11 by 12 into 2 by 9. When you multiply this, we get 22 is to 27. But this gives you the ratio of R is to Q, but we want the ratio of Q to R, which is, yes, which is the inverse ratio of this. So Q is to R is going to be 27 is to 22. So it is 27 is to 22. Now, just for a bit of information, there is another way of doing this. Suppose a question asked is, what is the ratio of P is to Q is to R? All three together, we need to do it in such a case, whatever is the common term, that is 11 and here 9, we take the LCM of that. So 11 and 9 is 99, so you can multiply the terms of this ratio by 9, so that you get 99 is to 108. And you want to make this also 9 because P is a common term. So you multiply this by 11 and you get 99 is to 88. So in this case, the continued ratio of all the three is 99 is to 108 is to 88. But in this particular question, it would be easier to do it by the process of division because we need to eliminate away P. So this is a case of how you can possibly obtain continued ratios from this. Let's see the next example, what we have. Yes, and of course, our answer is 27 is to 22. Okay, so what do we have next is this particular question. Daily earnings of the two persons are in the ratio 4 is to 5 and the daily expenses are in the ratio 7 is to 9. And obviously we know that if you subtract expenses from the earnings, we get the savings, or vice versa. You subtract the savings from the earnings, you get the expenses. Each saves rupees 50 per day. Their daily income in rupees are so and so. Now these kind of questions, we can do it by the elimination process faster. Now it's told the daily earnings of two persons are in the ratio 4 is to 5. So this in any case is not possible, because here the earnings are in the ratio 5 is to 4. So this is absolutely out of question. Okay, so 50 and 40 is definitely ruled out. Now it's also told that each saves rupees 50 per day. Now we're dealing with a real life problem. If out of, suppose the earnings were 40, you have the earnings is 40. From this, you're not going to save 50. So you'll get a negative number. Hence, this is not possible. So we have ruled out 40 and 50, we ruled out 50 and 40. So the only thing that is left is 400, 500 and none of these. Now I repeat once again. Now if you see, if you want to, you have this as the earnings and the expenses are so and so. So if you see, expenses are going to be whatever are the earnings minus the savings. Now, if we can check up, now in this case, these are the earnings and we know these are the savings and this is the earnings. So let us check in each of this case. Suppose in the first case, let's check this as the earnings and this as the savings. So we have 400 minus 50, which turns out to be 350. And the other option is the same. Using the same formula, it is 500 minus this 50, if you take this as the option, which turns out to be 450. So that means the ratio of the expenses is 350 by 450, 350 by 450. Let's check what we have. If you cancel by 5, you get 7 by 9. That means if you subtract, that is, if a person is earning, the ratio of the earnings is 400 and 500. One person earns 400, the other person earns 500. And he saves 50. So his expenses, if they take them as 350 and 450, it is turning out to be the ratio 7 is to 9. So by the process of elimination, without actually calculating it, you're getting it this way. So among these, this is the answer. Now this is a faster way of doing it. Actually, how you will do it is, of course, how you can actually understand the logic behind. We have done earlier some similar to this. If you see, there is 4 is to 5 are the earnings. So the earnings themselves will be 4x and 5x. From them, you're subtracting 50, 50 to get the ratio of the expenses. And this turns out to be 7 by 9. So then you do cross multiplying and find the value of x. But we have also a logical method of doing by elimination. So in such cases, this could be faster to do it. So our correct answer is going to be 400 and 500. Right. Yes, and it seems to be right. Now, let's take this particular example. Ratio between the speeds of two trains is 7:8. If the second train runs at 400 kilometers in 5 hours, the speed of the first train is what? Now, remember one thing, that speed is going to be whatever is the distance upon time. So if you see second train's speed is going to be the distance it travels, that is 400 kilometers, upon 5 hours, which is 80 kilometer per hour, is the speed of the second train. Now they are asking what could be the speed of the 10 kilometer or the first train. Now remember, the speed of any train has to be a multiple of 7. It cannot be 10 kilometer per hour because 10 is not a multiple of 7. It cannot be 50 kilometer per hour because it is not a multiple of 7. Now it can be 70 kilometer per hour. Quickly let's see, 7:8. If the ratio is 7:8, so the second train's speed is 8x and 80, and you get x as 10. That means the first train's speed is going to be 7x, that is 7 into 10, 70 kilometer per hour. So here also we have eliminated 10 and 50, because if this is the ratio of the speed, then the speeds have to be multiples of the terms of the ratio. We did a similar case regarding the angles too earlier once. So one of the examples here. So here these two are not possible, but we know 8 corresponds to 80. So if you take the common ratio factor, 8x is 80, so x is 10. So the same ratio factor is valid for this too. So you get 7 into 10, which is 70 kilometer per hour. So you get C. Our option is going to be 70 kilometer per hour. So this is a way, and yes, we have 70 kilometer per hour. Now, hence, in a few examples that we have done in ratios and proportions that we're going to do further, we come across and we can adopt the method of elimination. Let's see the next example, what we have. Okay, here we have a case wherein we have 8 people are planning to share equally the cost of a rental car. It could be anything, maybe 8,000 rupees. If one person withdraws from the arrangement, so the same 8,000 rupees are going to be now shared by 7 people. And the others share equally the entire cost of the car, then the share of each of the remaining persons increases by what? Now here we can take the total cost as x. You can even take it as 1,000, because again we are going to take a ratio of the final quantities. So it is, so here suppose we take it as x, you can even take it as 1,000. So let the rent be, say, rupees x. So the original share is going to be x by 8. And now the same x is going to be shared by 7 people. So the share per person increases to x by 7. So this is greater than this. So what is the increase is going to be the new share minus the old share, that is x by 7 minus x by 8. But it's asked, then the share of each of the remaining persons increases by what? Method? As a ratio, how many times does it increase? So whenever we find in terms of that, we always compare the increase with the original ratio, which was x by 8. So in short, it means increase in the rent upon increase in share upon original share, this ratio. This, if you simplify, turns out to be 8x minus 7x upon 56, if you take the LCM, into 8 by x, which will turn out to be x upon 56 into 8 by x, and it turns out to be 1 by 7. So the cost per person increases by 1 by 7 as compared to each person's cost increases by 1 by 7 times as it was earlier. So let's see among these options. So the option is going to be 1 by 7. So I repeat the simple formula. It's like calculating percentage increase. So it's going to be whatever is the increase, the new share, which is going to be more, minus the original share, divided by the original share. As compared to the original share, what is the increase? Find the ratio of that and you get the ratio by which the share has actually increased. And let's check the answer whether it tallies. Yes, we have it increasing by 1 by 7. Let's take the next example. Okay, now here we have a case of a continued ratio. So a bag contains amount of 187 in the form of 1 rupee notes, 50 paise coins and 10 paise coins in the ratio 3:4:5. In other words, the number of 1 rupee coin is 3 times and this is 4 times and this is 5 times. So that means you take the number of coins or rupees as 3x, 4x, 5x, because this is concerned with the sum of the actual numbers. So this is the number of coins, but we have rupees, hence each of these coins values have to be multiplied with the number of coins. So if it's a 1 rupee note, so the value is going to be 1 to 87, the total value. So the value of the 1 rupee notes, there are 3x 1 rupee notes into the value 1 rupee, plus there are 4x 50 paise coins is going to be 0.5. Or you can convert this to 3x into 100 plus 4x into 50. In that case, you're converting the rupees to paise. Remember the first part that we did in ratios. Whenever we're talking about ratios, all the quantities need to have the same units. Either you convert everything to rupees as we are doing in this case, or convert everything to paise. Plus the last one, that is 5x, 10 paise coins. So 10 paise is 0.1 times 1 rupee is going to be, this total value is 187. So that gives you 3x plus 4x into 0.5 is 2x plus 5 into 0.1 is 0.5. This turns out to be 87 and this turns out to be 5.5x is 187 and x will turn out to be 187 by 5.5. This, if you quickly calculate with your calculator, it turns out to be 34. It turns out to be 34. Now let's check among these. Hence, if it is 34, the coins 3 into 34 is 102. 4 into 34 is 1. 4 into 34 turns out to be 136. And 5 into 34 is 170. So our options are going to be 102, 136, 170. So among these, it is this as the option. So once again, you're multiplying the number of coins with the value of each of these. Remember that we need to convert all the quantities, the value of these quantities, either in rupees or in paise. If you're converting it to paise, you have to make this 100, this will be 50, this will be 10, and this again will become 18700, because even the 187 rupees has to be converted to paise. So let's check the answer. Yes, we have it there. It's 102, 136 and 170. Let's move on further. Okay, now we are taking up a case which is concerned with ratios of fractions. Remember the first thing that we did. It's the same process, you take it accordingly. Now let's read the question. Amount of 407 are to be divided among A, B and C so that their shares in the ratio is 1:4:1 by 5:1 by 6. So in that case, the respective shares of A, B, C are what? So if you see the ratios are 1 by 4 is to 1 by 5 is to 1 by 6. So their shares are actually each of these multiplied by x. So you have x by 4 plus and x by 5 and x by 6. And this total turns out to be this. And this has been given as 407. So we have to take the LCM of this. This turns out to be 60 by 4. So we have 15x plus 12x plus 10x. And it turns out to be 407. So we have 2237x is equal to 407 into 60. So x turns out to be 407 into 60 upon 37. So we have 407 into 60 into 37. Let's use a calculator and see what we have. We have 407 into 60 and divided by 37, and we get 660 over here. 660. So x is 660. Now this is not the answer. We need to divide each of these. So x by 4, x by 5, x by 6. So it's 660 by 4 and 660 by 5 and 660 by 6. So it's going to be, the last one is 110, and this is going to be 132, and this is going to be 165. So our answer is going to be 165, 132 and 110. So hence if the amount of 407 is to be distributed among A, B and C in the ratio 1 by 4 is to 1 by 5 is to 1 by 6, it means they have to be, the quantities have to be 165, 132 and 110. And if you see all these on adding, you do get 407, and of course we have seen when you divide them correspondingly you get these values. So our answers are going to be this. So let's see whether this tallies with our values. Yes, we do have it right here. We just need to be a little more cautious when you're making the calculations. Let's move on to the next problem. Okay. Now here we have again similar concern out here. The incomes of A and B are in the ratio 3:2 and their expenditures are in the ratio 5:3. If each saves an amount of 1500, then B's income is what? Now each one saves 1500 rupees. The options are 4500, 6000, 7500 and 3000 rupees. So if the incomes of, again you're using the same concept that expense is going to be income minus savings. So you're going to get a ratio. You're taking the incomes as 3:2. So you're going to taking the income as 3x and 2x. So it's going to be 3x minus 1500 upon 2x minus 1500 is the ratio of the expenses, which is 5/3. Cross multiply, you get 10x minus 7500 is 9x minus 4500. So if you shift this here and this here, you get x as 3000. So if you're getting x as 3000, then you're being asked to find B's income. So B's income is going to be 2x. So we have 2 into 3000, which turns out to be 6000. So B's income would be 6000, and in that case, if he saves 1500, then accordingly you get the ratio as 5:3. So our answer is going to be 6000. That is option number B. Let's check. And yes, we do have B's income as 6000. In this case, we need to do by actual calculations. Let's see what the next problem has in store for us. Okay, now here we have a case of 40 liters mixture of glycerine and water. The ratio of glycerine and water is 3:1. The quantity of water is added in the mixture in order to make this ratio 2:1. So there are totally 40 liters, out of which 3 parts are glycerine and 1 part is water. And to this you're adding water. The ratio is definitely going to change because the amount of glycerin has not changed, neither decreased nor increased. But the amount of water has increased, so the ratio will increase more in favor of water accordingly. So if you have 40 liters of mixture of glycerine and water and the ratio of glycerine to water is 3:1. So you take the amount of glycerine as 3x and the amount of water as 1x. And this total is turning out to be 40. This gives you x as 40 by 4, which is 10. So the amount of glycerine is 3 into 10, 30. And the amount of water is 10. So out of 40 liters, we have 30 liters of glycerine and 10 liters of water. Actually, you can just look at it and tell out of 40 liters, if the ratio is 3:1, it is 3 parts, that is 30 liters and 1. Now, to this, this is the amount of glycerine, this is the amount of water. Now, to this, you're adding some amount of water. So, it becomes from 10, it becomes 10 plus x. But mind you, there is no increase in the amount of glycerine. And this new ratio is 2:1. So, you get 30, the amount of glycerine remains the same. But the amount of water becomes 10 plus x, which is turning out to be 2:1. That means the denominator is half of the numerator. So if half of the numerator is 15, which means that 10 plus x is 15. 10 plus x has to be 15 and x will turn out to be 15 minus 10, 5. Or you can cross multiply and you get the same thing. You get 30 into 1 is equal to 20 plus 2x. Again here x turns out to be 5. In short, you need to add 5 liters of water to this particular mixture and it turns out to be the ratio, new ratio will turn out to be 2:1. So that means you need to add 5 liters. So our answer is 5 liters. Let's verify this. And yes, we do have 5 liters. More to come. Let's see what further challenges we face here. Okay, now here we have the next problem is, in what ratio should tea worth amount 10 per kg be mixed with tea worth 14 per kg so that the average price of the mixture may amount to 11 per kg. Now average obviously is going to be total cost upon the total number of kgs or total quantity of tea. So, suppose you have the rate here and you have the quantity. So, suppose the first one's rate is 10 and the second one's is 14, and suppose you take x kgs of the first kind and y kgs of the second. So if you look at it, the total cost is going to be 10x plus 14y upon the total quantity, which will be x plus y. So the average is going to be 10x plus 14y upon x plus y, and this average rate has been given as 11. So the total quantity of the tea upon, so you multiply it again, just as the examples in rupees, you multiply the quantity with the rate. So this turns, we can cross multiply. Remember, in this case, we cannot find x and y individually. We are concerned about the ratio. So we need to find x is to y. So it's going to be 10x plus 14y is 11x plus 11y. So this turns out to be 14y minus 11y is 11x minus 10x x. So that means x turns out to be 3y. So in other words, x by y is going to be 3:1. That means we need to mix these two quantities of tea in the ratio 3:1. Let us check. You do have this option 3:1. So we need to get the answer as 3:1. Let's check it. And yes, we do have the option 3:1 as the right solution to this particular question. So it's going to be the total cost upon the total quantity will give you the average rate as in this particular case. Now let's move on to the next problem. So let's take this example. The ages of two persons are in the ratio 5:7. 18 years ago, their ages were in the ratio 8:30. And their present ages in years are so and so. Now, if the ages of the two persons is 5:7, obviously this will not work because this is in the ratio 7:5. So we need to see between B, C and D. So let's see how you have the ages of two persons are in the ratio 5:7. So that means you need to take their ages as 5x and 7x years. 18 years ago, this one's age was 18, 5x minus 18. This one's age was 18, 7x minus 18. And this ratio was 8:13. So we have 13 into 5x minus 18 is equal to 8 into 7x minus 18. This turns out to be 65x here, and quickly let's see what we have. So we have 13 into 5x, which is 65x, and you have 13 into 18, which turns out to be 234, and here you have 8 into 7x, which is 56x, and this is 144 minus 144, and here you have 65x minus 56x is minus 144 plus 234. This turns out to be 90, and this is 9x, so x turns out to be 10. X turns out to be 10. In that case, 5x is 50 and 7x is 70. So our solution to this particular problem is a combination of 50 and 70. 70 and 50 in any case is out. So 40, 56 is also not out as per this. So we have 50 and 70. So that means the present ages are 50 and 70 years. So this is the right option. And yes, we do have 50 and 70 as an iteration. Let's check the next question. Okay. Now here we have an option here. We have this particular question here. The students of two classes, A and B maybe, are in the ratio 5:7. If 10 students left from each class, the remaining students are in the ratio 4:6. Then the number of students in each class is what? Now, let us see the various options over here. Students are in the ratio 5:7. Now, if you're taking them as 5:7, the original ratio cannot be 30 and 40 because 30 and 40 is not divisible by 7. About this also, 25 and 24, it's not possible because 24 is not divisible by 7. 40 and 60 is not divisible by 7. So among these three, A, B and C are definitely not the option. So obviously 50 and 70 will be the option. If there was a case of none of these, we may have to check any other option which is not possible to eliminate. But in this case, without calculating, as I told you, if you have a particular ratio, and then in that case, the quantity should be actually multiples of the antecedent and consequent. So here the consequent 7 is not a factor of these terms over here. So only in this case you have. So the correct answer is going to be 50 and 70. Let's see. Yes, and we do have the options as 50 and 70.